Okay, this is day 2 of Newton's method. Today we're going to be looking at how you can use Newton's method to actually approximate where two graphs intersect. Now, if you don't know how to graph on your graphing calculator and find the point of intersection, it doesn't have to be the point of intersection, you just need to find the approximate point, the approximate x value at which they intersect. Please bring that up during class. I'm going to tell you that the approximate point that I'm going to use where they intersect is 2.9. So I'm going to start there today. You do need to know the hints, okay? The hint is that we are going to let h of x equal f of x minus g of x, and that's what we're going to be using as the function for the intersection. So what we're going to do h of x really quickly by doing your g of x 1 over. What that ends up giving us then is for h prime of x 1, and then the derivative of this right here. This is truly, I'll do this off the side. You've got x squared plus 1 to the negative. You bring this out front, which would make it positive. You rewrite it, and you lower it by 1. Take the derivative of what's on the inside, which is 2x. So you end up getting plus 2x over x squared plus 1 squared. Then what you want to do is, these are all really just h's, so we're figuring out the Newton's method using the table, but we're going to be using the h and not the f. This is where the two graphs intersect. We can use this h to help us figure out where those graphs are intersecting. So what I'm going to do is plug in 2.9, and if I plug 2.9 into my function f of x, I end up getting 1 divided by 2.9 squared and I didn't get it entered in properly because I forgot the plus 1. Once again, this is going to take me way longer to enter in the calculator, and so what's going to do is cause the videos to be rather lengthy. What I am going to do is start on this and then fill in the chart, and then we can talk about any issues that you're having when you're plugging stuff in. So I did get negative 0.0063, and then what I would get when I plug in it into f prime is negative 0.9345. Dividing those two values gives me 0.0067. Then when I subtract 2.9 minus this, I get 2.8933. Bring that new value down, 2.8933. Plug that value in for h of x. You get 0.0000. So I know I'm going to be very close. Plug that value into this value into h prime. You get negative 0.9341. Again, when you divide those, it's really not 0 that you're dividing by, or 0 divided by this, so you do get 0, and then when you subtract those original, you end up with the same value, this minus 0. So we are within the 0.001. Again, if you have problems with your calculator, please let me know. I know that I'm not spending time showing you how to enter things in the calculator.